Mars is known today for being a completely desert, dry, and cold planet. However, it hasn't always been like this, and the red planet used to resemble what Earth is like today. But has it really ceased to be entirely what it was in the past? Well, apparently Mars might not be as dry as we imagine. But we also shouldn't expect to find a large amount of water like we have here. There's a powerful camera in Mars orbit today that has directly proven this issue when it observed what could be direct evidence of water flowing on the surface. In today's video, we're going to see the extremely rare records of water on our interplanetary neighbor. Water may seem rare in space, but it's not quite like that. It exists throughout the celestial bodies. Seriously, there's evidence of water even on Mercury, but the fact is that liquid water, capable of flowing on the surface as we know it here on Earth, is indeed quite rare, at least until the sending of a specific satellite to Mars. In reality, when we think of water, we need to consider that it can also exist in the gaseous and solid form. And here, even on the Moon, there's evidence of its presence there. But perhaps it's unfair to talk about interplanetary water and not mention Europa and Enceladus here. Earth, which appears to have a lot of water, doesn't even come close in proportion to what we find on these moons of Jupiter, and respectively, Saturn. Enceladus's situation remains intriguing to this day, as we've already had the opportunity to observe up close the imposing jets of water expelled from the fissures on its surface. The images captured by the Cassini mission were truly spectacular, revealing a scenery rarely seen in other regions of the solar system, where a phenomenon creates stunning landscapes in the form of immense geysers. As the spacecraft passed through these plumes, it detected simple molecules such as carbon dioxide, methane, ammonia, and traces of carbon monoxide, along with other salts. These observations indicate the presence of hydrothermal activities in the underground ocean that gives rise to these jets. According to researchers, such activities may trigger more complex chemistry and even favor the existence of life in the depths of these natural satellites. In other words, these hydrothermal vents may provide suitable environments to harbor microorganisms, as occurs in thermal springs here on Earth. The existence of these geysers also suggests that these moons have a source of energy, possibly coming from the gravitational forces of Saturn itself, or, in the case of Europa, from Jupiter. This energy plays a crucial role in maintaining these liquid oceans beneath the frozen surface, generating friction due to intense tidal forces and, consequently, the heat needed to keep all this water in a liquid state. Well, but the Martian question may not be as simple, as here is a planet much larger than a moon, and much more complex processes may occur over billions of years. But even so, robots like Curiosity or Perseverance, they travel short distances and do not cover a very large area of the Martian surface. This crucial task falls to satellites in space, where Mars has already had much of its surface mapped and mainly monitored over time. Monitoring a specific region is important here because we can create a true time lapse of days, months, or years, revealing seasonal changes on the planet's surface, including the presence of water flowing there. Firstly, it's a fact that Mars has a lot of ice, but most of this ice ends up not being water, but frozen carbon dioxide. However, just like on Earth, the red planet experiences seasons, and when Martian summer arrives, phenomena can be observed by comparing images taken on different dates. This time, the task of capturing such scenarios falls to a satellite called the Mars Reconnaissance Orbiter, which boasts a high-resolution telescopic camera. The orbiter as a whole is equipped with various scientific instruments, but there's one special instrument called HiRISE, which can discern details on the Martian surface with a resolution of 30 centimeters. Well, you know what that means? From space, at an altitude of 300 kilometers, this camera can achieve a resolution of 30 centimeters per real pixel of the red planet's surface. Using this magnification power, astronomers have already managed to see active water flows there. Notice how the streaks on the surface darken as the liquid flows down the Martian slopes, of course, due to the seasonal warming of the planet. However, it's important to emphasize that before we conclude that there are large amounts of surface water on Mars, it's necessary to consider that this occurrence happens under very specific conditions. At this moment, the water must be mixed with various minerals to lower its melting point, unlike what we're accustomed to here on Earth. It's worth remembering here that Mars has only 1% of Earth's atmospheric density, highlighting that the brief existence of water in a liquid state is simply breathtaking, and imagining that Earth is not the only planet to have liquid water, although Martian conditions are not so favorable. Unfortunately, without atmospheric pressure, water evaporates easily. Researchers still suggest that we're likely witnessing a very shallow underground flow, and of course, with enough water to reach the surface, which explains the darkening with the increase in average surface heat on the planet. In another series of impressive images, we see the same pattern of lines emanating from the surface. The slopes observed here measure up to 1,200 milliliters where water can flow and descend, where once again, salts can maintain the water flow even at temperatures where pure water would freeze, also reducing the rate of evaporation. It all depends on what is mixed in this water. In reality, there are numerous satellite records showing these slopes becoming wetter over the weeks. But it's worth noting that there are also those who argue that perhaps this isn't exactly water, but dark sand sliding through lighter sand above. Either way, the idea of water flowing there seems to better explain the various phenomena observed in different areas of the red planet. But you're probably wondering right now if we could drink this water. In short, the answer is no. At least I don't recommend it. Remember that this water only exists there because it's mixed with various salts. Therefore, it's likely that any water found would be extremely acidic or even highly salty, with various toxic metals mixed in. The Martian flows exist. Mars may be richer in water than we imagine, and NASA's powerful camera has proven that. However, if one day we want to drink this alien water, we'll have to treat it very carefully. Mars then becomes one of the few celestial bodies to maintain liquids on its surface. Folks, if you enjoyed this video, don't forget to hit the like button down below. It really helps out. And if you're not subscribed to the channel yet, I invite you to hit the subscribe button. Until next time.